So welcome to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths Higher Paper of 2022, Higher Paper 3, which is a calculator paper. Now, as always, I'll include a question breakdown so you can see which questions refer to which topic in the description below. So let's get started on this November 2022 Higher Paper 3, which is a calculator paper. So looking at question 1, it says 2 to the power of what gives you 32. So if you just go through your powers of 2, so you've got 2 to the power 1, 2 to the power 2, 2 to the power 3, and just go up into doubling your numbers. So you've got 2, 4, 8, 16, 32. You'll see that it's 2 to the power of 5. For question 2, it says what is 1.8 times 10 to the power of minus 4 as an ordinary number? And the correct one you need to circle is going to be the third option. Moving on to question 3, we just want to expand these brackets. So 6 x squared times x to the power 3 is where we add the powers, so that's going to be 6x to the power of 5, and then 6 times 2 is 12, and we've got no x's, so it stays the same, and that is going to be the third option. Then moving on to question 4, it says x is between 30 and 300. X is 200% of y, so basically it means that x is double of y. So then to get y, what we need to do is halve the upper and lower bound. So it's going to be 15 and it's going to be 150. So that is our second option. Moving on to question 5, it says ABCDE is a pentagon. Work out the area of the pentagon. So what you need to do is you need to establish that this is two shapes. We've got a trapezium and we've got a triangle. So here, so the total area is going to equal the area of the trapezium plus the area of the triangle. Now, if you remember your formulas, the area of a trapezium is going to be a plus b multiplied by h divided by 2, and the area of a triangle is base times height divided by 2. So working out each of those, so if you just write area of the trapezium, then that is going to be our two parallel sides, which is 14 and 20. So we've got 14 plus 20 multiplied by the height, which is 11, and we're going to divide all of that by 2, in which I should have an answer of 187. Then if I work out the area of the triangle, which although is an angle, I do know the height and the base, well, that's going to be 10 times 7 divided by 2, which is 35. Now if I just add these two numbers up, then I get my total area, and that's going to be 187 plus 35, giving me a total of 222, and that's centimetre squared. Then moving on to question 6, it says that Joe, Kim and Lisa each have an amount of money. Joe has £72. Joe's amount to Kim's amount is in the ratio of 65. Lisa's amount is 1.5 times Joe's amount. Show that in total they have less than 250. So to start off with, if we just start by writing the three people, so we've got Joe, Kim and Lisa, and we know that Joe has got £72, so let's just write £72. We know that the ratio of Joe to Kim is 6 to 5, and we know that Lisa has 1.5 times more than what Joe is. So if Joe has X amount, then Lisa is going to be 1.5x. So looking at this, what we can see is, well, if I take that 6 parts equals £72, so therefore 1 part is going to be 72 divided by 6, which if I do that on my calculator gives me 12. And so then Kim's amount, so Kim equals 5 parts, so that's going to be 12 times 5, which is 60. So Kim's going to have £60. So then if I know that X equals £72, then 1.5x is going to be 72 times 1.5, and that gives me an answer of 108. So then all that's left to do is to have the total amount. So the total amount is going to be 108 plus 60 plus 72, and that comes up to a total of 240, and then I can just write which is less than 250. Then moving on to question 7a, it says here is a rule for a sequence. After the first two terms, each term is the sum of the previous two terms. So in other words, we're looking at a Fibonacci sequence. And it says the first term is 33, the second term is x, and the fourth term is 73. Work out the value of x. So with this, if I start by just having my four spaces and start filling this in, so the first term is 33, the second term is x, and the fourth term is 73. Now to work out this third term, what I've got to do is just simply add the previous two terms together. So that's going to be 33 plus x. And then 73, well, that's going to be these two terms added together. So it's going to be this plus this equals this. So what I've got is I've got x plus 33 plus x equals 73. So that becomes 2x plus 33 equals 73. So 2x equals 40, and so x equals 20. Then moving on to 7b, it says that an expression for the nth term of a different sequence is n minus n squared. Ruth says all of the terms will be negative because n squared is always greater than n. Is she correct? Well, again, there's a couple of reasons which you could write this, but if we could then say that the first term, if we actually write down what the terms are, so the first term is going to be 1 minus 1 squared, which is 0. So is 0 negative? No. So, and again, because the first term is this, which is not negative. You could also say something along the lines of that all terms are negative after the first term. So she's almost correct, but she's kind of ignored the very first number in the sequence. Then moving on to question 8, it says here is some information about members of a clubs A and B. It says work out the total height of members of club A over the total height of members in club B. Give your answer as a decimal. So here, if we have the total of club A, so that's going to be, so the total height is going to be 24 times 1.8, and that gives me 43.2 meters. If I then do the same for the total height of club B, that's going to be 20 multiplied by 1.92, and that comes up to a total of 38.4 meters. So then performing the calculation, I've got 43.2 divided by 38.4, and that comes up as an answer of 1.125. Then moving on to question 9, it says P and Q are points. The x-ordinate of Q is 4 more than the x-coordinate of P, and the y-ordinate of Q is 5 less than the coordinates of P. Work out the gradient of the straight line through P and Q. So if we have just a point of this P, now if Q is 4, the x-ordinate of Q is 4 more than x, and then the x-ordinate of P is going to be somewhere along this side here. So I can imagine that it's going to be, let's say, there. Now if the y-ordinate is less, that means it's going to be down by, and that's going to be 4, and that's going to be 5. So point Q is going to be somewhere there. Now the question is asking me to work out the gradient of the line that connects these two up. So here you can see I'm going to end up with negative gradient because I'm going down. Then if I work out the base and the height of that triangle, so the height is 5 and the base is 4, So then the gradient of PQ is going to be minus 5/4, which is, or minus 1.25. So either write it as a fraction or you can write it as a decimal. Then moving on to question 10, it says here are the results after 250 spins of a coin. The coin is spun an extra 50 times. After all 300 spins, the relative frequency of heads is 0.49. For the extra 50 spins, work out the ratio of the number of heads to the number of tails. So first of all with this, let's just work out after 300 spins, the number of heads is going to equal 0.49 multiplied by 300, which gives me an answer of 147. So that means then that the number of tails is going to be 300 minus 147, which is 153. So then what I need to then do is, in terms of the 50 extra spins, so the head count is going to be the difference between this number and this number, so it's going to be 147 minus 128, which is 19, and then the number of tails is going to be this number minus this number, so it's going to be 153 minus 122, which is 31. So then the ratio is going to be, for heads to tails, is going to be 19 to 31. Then moving on to question 11, it says part of a running track is an arc of a semicircle joined by a straight line. The semicircle has a diameter of 45 meters and the straight line has a length of 75 meters. Abby runs along the part of the track in 18 seconds. Work out the average speed, and we need to give our answer to two significant figures. Now in terms of average speed, so speed equals distance divided by time. So what I need to do is I need to work out what the distance is of the track. So if I look at the track in two different sections, that this section here is a semicircle, so that's going to be pi times r squared divided, actually next that's going to be 2 pi r, that's the area, so it's going to be 2 pi r divided by 2, or pi times d divided by 2, whichever formula you want to use. So here it's going to be basically 45 pi divided by 2. So that's the total length of that green line. Then for this blue line here, which I'm going to do in blue, not green. So this part here, that is 75. So this here, this number here, now I'm going to leave it in terms of this, is the total distance. Now we know that the time is 18 seconds. So then the speed is going to be the total distance, which is 45 pi divided by 2 plus 75 divided by the time, which is in 18 seconds. And we know that the units are going to be in meters per second. So then if I type that all into my calculator, I get an answer of 8.1, and that's meters per second. So moving on to question 12, it says triangles ABC and DEF are shown on a grid, and the question is asking us to describe the single transformation that shows that the triangles are congruent. So for this, depending on which triangle you're seeing as the image and which one you're seeing as the object, so if you're going from ABC to DEF, then it's going to be a translation. And if we pick a point, so let's go for A and the corresponding points, so that's going to be 1, 2, 3, 4, 5, 6. And it's going to be going 4 up, so it's going to be translation with a column vector of 6, 4. Now, if you're going from DEF to ABC, then it will still be a translation. However, the column vector will be going in the opposite direction, so that would be -6 and -4. So you can either give that first answer or you can give the second answer. Moving on to question 13, it says that a fair ordinary dice is rolled and a counter is taken at random from a bag. The tree diagram shows the probabilities. Here we've got our tree diagram, and the first part says, how do the probabilities show that all counters in the bag are red, blue or green? And the reason for this is because all the probabilities in each branch equal 1. So something along those lines would be absolutely fine. You could say that the probabilities are all exhaustive. So then moving on to question 13b, it says circle the probability that the counter is red or blue. So the probability that it's going to be red or blue is basically we can either have odd or even. So that's going to be either, so going back to this here, if I just write B, so we want red or blue. So then here what we're looking for is the fact that if we roll an even, then that's going to be, and I just put red or blue. So that's going to be 0.5 times, and then it's going to be 0.4 equals, or we could have odd and red or blue. And that's going to be 0.5 times 0.4. So that's going to be 0.2, that's going to be 0.2, and it's going to be either of those. So the answer is going to be 0.4, and so that is going to be our fourth option. For the next one, it then says circle the probability that the dice lands on an even number and a blue. So even, so for C, we want even, so it's going to be this one, and a blue. So even and blue, well that's going to be 0.5 times 0.3, giving me an answer of 0.15, and that is our first option. Then moving on to question 14, it says here are two solid cubes x and y. The mass of x is 10.976 and the area of each face of x is 784 square centimeters. Zion wants to know the density of y, and he assumes that y is identical to x. What density should he get for y? Give your answer in grams per cubic centimeter. So first things first, in terms of the mass, we can see that it's given to us in kilograms. So that in grams is going to be 10.976 grams, because there are 1,000 grams in a kilogram. So the next thing we know is that the area of each face of x, so this area here, is 784. Now if I just label this side as x, and it's a cube, so therefore 784 is equal to x squared. So that means to work out the length of a square, it's going to be the square root of 784, which is 28. So then to work out the formula for density, so density equals mass over volume, that if the cube has a length of 28 by 28 by 28 and a mass of 10.976, so 10.976 grams divided by 28 times 28 times 28, and that's in centimeter cubed, then if I work that all out on my calculator, I get 10.0976 divided by 21952, and that comes up to an answer of 0.5 grams per centimeter cubed. Then moving on to 14b, it says in fact the mass of y is less than the mass of x and the area of each face of y is greater than the area of each face of x. So basically what you're doing, if you look at the fraction, we're going to make this smaller and we're going to make this bigger. So in other words, in terms of the fraction, we're going to get a smaller fraction. So that means that we'll get less density. So that means that the correct box we need to tick is going to be the first one. Then moving on to question 15, it says that a mobile phone takes 2 hours to charge from empty. When the phone is being charged, the current flow into the phone starts at full current flow, which is 100%, continues at current flow for a period of time, and then gradually decreases until the phone is fully charged. This is shown by graph A below. Graph B then shows the percentage charge in the phone when charging from empty. So again, I'm sure we can all relate to this situation. It says that Megan's phone is empty of charge. She starts to charge her phone at 10 a.m. Using graph A, estimate the time when the current flow starts to decrease. So using graph A, so we're looking for when does the battery start losing power? Well, it starts losing power at this point here. Then if we work out how many minutes there are, well, that each little box represents 2 minutes. So this little distance here is 6 minutes, which means at this point it's going to be 26 minutes. So it starts losing charge after 26 minutes. So from 10 a.m. we're going to add 26 minutes. So it's going to be at 10:26. It then says using graph A and B, estimate the percentage charge in the phone when current flow is 40%. So for this, what we need to do is we need to go up to graph A. We need to go up to 40%. And let me use a different color. And we want to see how much time is elapsed. So it's this point here, and that is 36, at 36 minutes. So here we've got 36 minutes. Just going to make a little note. So then what we need to do is then find 36 minutes on this graph here, on graph B, which is there. And we project up until we hit the curve, and then we read off the charge on the phone. So that is going to be at 80. It then says for part C, using graph B, estimate the rate of increase in the percentage charge when the phone has 90% charge. So what we need to do here on graph B is first of all find 90%, which is there. So let me just draw a little arrow. So that's 90%. And then what we want to do is continue there until we hit the curve. Now what we want to do is we want to work out the gradient at this point. So to do this, what you need to do is you need to draw a straight line with a ruler. So it touches the curve only at that point there. And then what you then want to do is to turn that into a right angle triangle and then work out the gradient. So you then want to work out this distance here, which I work out to be about 20. And looking at the base of this, so each little box is 2. So I've got 3, 8, and 10. So then it's going to be looking at 20 minutes. So then it's going to be 20 over 20, which I make out to be 1. And again, there's so many different answers you could have, but one thing to get the 2 marks, what you need to do is to draw a tangent at 90 and then work out the gradient accordingly. Now your answer might be slightly different to mine depending on your triangle, but roughly your answer should be hovering around 1. Moving on to question 16, it says that h is inversely proportional to the cube root of L. When h is 7, L is 64. Work out an equation connecting h and L. So first of all, we start by writing this statement here using math notation. So h is proportional to the inverse of the cube root of L. Now you want to make sure that your cube root looks like a cube root, not 3 root. Then we replace the proportional symbol with equals k, and again that's going to be the cube root of L. And then we substitute our numbers to try and work out what k is going to be. So I've got 7 equals k over the cube root of 64. Cube root of 64 is 4, so that's going to be k over 4, so k equals 28. So then going back and substituting this into our formula, we get h equals 28 divided by the cube root of L. And there is my formula. Then for question 16b, we just want to substitute that number L equals 2744 into the formula. So h equals 28 divided by the cube root of 2744. And if I type that straight into my calculator, I should have the correct answer of 2. Moving on to question 17, it says A, B, C are points on a circle with centre O. BD is a tangent to the circle and OCD is a straight line. Calculate the angle of angle X. Well, you can see you've got arrowheads, so from this we can see that this angle here is going to be twice the size of the angle at the circumference, so that's going to be 64. We know that a radius meets a tangent at 90 degrees, so then I can then work out what X is. So x equals 180 minus 64 minus 90, which gives me an answer of 26 degrees. Then moving on to question 18, it says rearrange, and we've got this formula to rearrange. So first of all, we can start by multiplying out the brackets. We get 9m plus 8m minus, oh, what happened there? Minus 4 equals p squared minus pm. We can then combine these two things together, so we get 17m minus 4 equals p squared minus pm. We then want to get everything with m on one side and everything else on the other, so I've got 17m plus pm equals p squared plus 4. Then from this we can then take factorize this. So we've got m and I've got 17, and it's going to be, oh, that should be a plus. So that's going to be a minus. And minus p. And as you can see now, I've only got one m, so the only thing I've got to do is take this bracket over to the side. So m equals p squared plus 4, all divided by 17 minus p. And there we go. Now, if you wanted to include brackets, that's absolutely fine, but that's what you should have. Then moving on to question 19, it says that a circle has centre at 0, 0 and passes through 0, 11. Write down the equation of the circle. Well, if it passes through at 11, 11, then that means that the radius is going to be 11. So then the equation of the circle is going to be x squared plus y squared, and you can either write 121, or you could write it as x squared plus y squared equals 11 squared. So any of those two would be absolutely fine. Moving on to question 20, it says there should be a train leaving a station every hour from 7 AM. No trains leave early, and the probability of the first train leaving on time is 0.9. For all other trains, if the previous train did leave on time, then the probability that the train leaves on time is going to be 0.8. If the probability of the train did not leave on time, the previous train did not leave on time, then the probability that the train leaves on time is going to be 0.65. Definitely take some time to read and understand which of those questions that is going to be. So this one here is, if we say that L represents late and not L means on time. So this first statement, so this is when we've got not late is 0.9, and that's the first train. Then the previous train, so if the previous train is on time, so if it's L and on time for not late, so that's going to be not late, that's 0.8. And this one, if the previous train is late and not late, then it's going to be 0.65. And it's this is the one that we're looking for. Okay, so the first question then says, work out the probability that the first 3 trains are on time. Well, the first train is on time is 0.9, so that's the first train. Then if the previous train was on time, then the probability that the next train is on time is going to be 0.8. And if the previous train was on time, then the next train being on time is 0.8. So if I type that all into my calculator, as a decimal I should get 0.576, or as a fraction we get 72 over 125. For question 20b, it says the 2 p.m. train does not leave on time. Work out the probability that exactly one of the next 2 trains does not leave on time. So we know that the 2 p.m. train is late. So then the next train and the one after that is, so this is late. So we can either have for one of these 2, now we're only focused on these 2 trains. So the probability that the next train is either, we either want late and not late, or we want not late and late. Let me just get rid of that O. So these are the 2 situations that we've got and we need to work out. So it says in the previous statement that if the previous train is late, then, which it is, so we're looking at this second statement here, that, because obviously the 2 p.m. train is late, so the next train being on time is 0.65, so this is 0.65, and the probability of the other train being late is going to be, this next train going to be late, is 0.35. Now, and, let me just write that in green, and means times. Now, if the previous train is late, then the probability that the next train is not late is going to be 0.65. Now, if the previous train was late, the probability of the other train being late is going to be 0.2. So then working out each of these individual probabilities, we get 0.2275, and this one's going to be 0.13. And if I then add these 2 probabilities together, I get an answer of 0.3575. Then moving on to question 21, which I'm going to zoom out a little bit. It says shape A is enlarged to shape B, and the question is asking us to circle the scale factor of the enlargement. Well, we can see that it's been flipped, so it's going to be a negative. So if it's flipped, it's going to be a negative. And we're going from A to B, so it's gone smaller. So the scale factor is going to be less than 1. So looking at this side here, that's got a side of 6, and the corresponding side is 3. So then the scale factor is going to be -0.5. And so it's the first one I want to circle. It then says write down the coordinate of the center of enlargement. So for this, if I just get rid of those little markings. So what you want to do to work out the center of enlargement is basically join the corresponding points on the object and the image. And let me just, now technically you only need to do this for 2, but if you want to make sure, you can do the third. And let's do this one here. And hopefully you can see that my center of enlargement is going to be there, and the coordinate of that is 2 minus 1. Then moving on to question 22, it says simplify fully, and we've got this algebraic fraction. Now the question is asking us to combine them and write the answer as a single fraction. So at the moment we've got 3 terms, 2 of them are written as fractions, but the third one isn't. So if I just write that over 1, I've now got 3 fractions. Now with this, what I want to do is I need to try and find a common denominator. Now here, to find the common denominator, the easiest way is by multiplying all the denominators together. So here my common denominator, or common denom, is going to be 3 lots of x plus 1. So if I set up my fraction, I've got 3x plus 1, and I've got plus 3x plus 1 plus 3x plus 1. Now for this first fraction, I need to multiply that by 3. So I multiply the numerator by 3, so that becomes 2 times 3. Then for this second fraction, well, I need to multiply that by x plus 1. So I multiply both the top and the bottom by x plus 1. So that's going to be 7 minus 5x, then x plus 1. And then in this third one, I want to multiply the denominator by 3 lots of x plus 1. So that's going to be 4x multiplied by 3x plus 1. So now that my denominators are the same, I can add the numerators together and we can do a bit of simplify along the way. So looking at this, we get 6 plus, and then if I simplify, which I'm going to run out of colours, so let's go for this here. So if I simplify that, I get 7x plus 7 minus 5x squared minus 5x. And then if I simplify this numerator, I get 12x squared plus 12x. And that is all divided by 3 lots of x plus 1. Now, I'm not going to write 3x plus 3 because I've got a feeling that the top is going to hopefully maybe potentially factorize, in which x plus 1 may be a common bracket. So let's have a look. So if I neaten all of the numerator up by collecting all the like terms together, so here I've got 12x squared minus 5x squared gives me 7x squared. Then looking at the x's, I've got 7x, take away 5x, plus 12x, which is 14x. And then looking at the constants, I've got 6 plus 7, which is 13. And that's all over 3 lots of x plus 1. Now I just need to check if the top factorizes, in which it doesn't. So my final answer, believe it or not, is going to be that. Then moving on to question 23, it says Alec makes a bowl of dog food from a solid wooden cone. The sketches show how the bowl is made. The cone has a radius of 9 centimeters and a perpendicular height of 30. The smaller cone has a radius of 6, is removed. And we've got a formula for the volume of a cone, and we've got the volume of a hemisphere. And the question is asking us to work out the volume of the remaining wood that forms the bowl. So for this, now I'm going to kind of zoom out just so that we've got both of these on course. Now for this, what we need to do is basically to work out the volume of this bottom bit in terms of this. Now these two triangles are going to be similar because it's taken from the same triangle. So the radius at the height of this is, first of all, I need to work out the length scale factor. So that's going to be 9 divided by 6, which is 3 over 2, which is 1.5. So then to work out this new height, it's going to be 30 divided by 1.5, and that's going to be 20 centimeters. So then to work out the volume of this cone, so this shape here, the frustum, is going to be the volume of the big cone minus the volume of the small cone. And the volume of the small cone, or the big cone, is going to be 1/3 times pi times the radius, which is 9, times the height, which is 30. And if I simplify all of that, I get 810 pi. Then if I work out the volume of the small cone, then that's going to be 1/3 times pi times 6 squared times 20, and that comes up to 240 pi. So then this volume here, so the volume of the frustum is going to be 810 pi minus 240 pi, which equals 570 pi, which I'm just going to leave in terms of pi for now. So then what I've then got to do is then work out the volume of the bowl. Now the volume of the bowl is the volume of the frustum minus the volume of the hemisphere. Now the volume of the frustum, I've already worked this out, is 570 pi minus, now the volume of the hemisphere, well the formula is here, so I'm just going to put that in brackets. So that's going to be 2/3 times pi times the radius, which is 6 cubed. So then from this I then get an answer of 570 pi. If I work out all of this, I get an answer of 144 pi. Taking the two answers away, I get 426 pi, or I could write my answer as a decimal, giving me an answer of 1338.3, and that's centimetre cubed, and that's to 1 decimal place. Then moving on to question 24, so let me just zoom in on this. And it says that on the same day, Kate buys a car for £14,000 and she buys a painting for £5,000. The value of the car decreases by 35% in the first year and then 10% each year. The value of the painting increases 4% each year. Show that the painting becomes worth more than the car during the 5th year. Now for this, it's worth 5 marks, so there's going to be quite a lot of working out needed for this one. So what we're needing to do is we need to work out the value of the car and painting in the 4th and 5th year. So if we look at the car in terms of the 4th year value, well, that's going to be the original amount. Now the first year it decreased by 35%, so that's going to be 0.65, and then for 3 years it increases by 10%, so that's going to be 0.9 to the power of 3. Now if I type that all into my calculator, what I'm going to do right now, to the power of 3, I get an answer of 6,633 and 90 pence. Then the value of the car in the 5th year is going to be 1400 times 0.65 times 0.9 to the power of 4. Now I just want to make sure that that looks like a 3 and not a 2. So let me just write that slightly up. And if I then times that by 0.9, I get a value in the 5th year of 5970.51. Now if I then do the calculations for the painting in terms of the 4th year value, now this one's going to be relatively straightforward, so it's going to be 5,000 multiplied by a percentage increase of 4%, so that's going to be 1.04 to the power of 4. So 5,000 times 1.04 to the power of 4, and that comes up as 5849.29, and that's to 2 decimal places. So you can see in the start of the 4th year that the car was still worth more. Then if I then work out the painting in the 5th year, or the 5th year value, we're going to do 5,000 times 1.04 to the power of 5, and we get an answer of 6083.26, and that's to 2 decimal places. So as you can see, that the value in the 5th year, so at the start of the 4th year, the car was worth more, and you might want to work out the difference between the two. So 6633.9 take away 5849.29, and that comes up to, we could say, by £784.61. But at the start of the 5th year, the painting was worth more. And again, we can then work out the difference by doing 6083.26 take away 5970.51 by £112.75. So make sure you are writing that little bit of statement, but I would generally say that this is going to be worth 1 mark, that's going to be worth 1, that's going to be worth 1, that's going to be worth 1, and then a comparison to show that the value has shifted from the car to the painting at the start of that 5th year. Then moving on to question 25, it says 2 sides of a triangle are measured to 1 decimal place. The angle between the sides is measured to the nearest degree. Work out the upper bound for the area of a triangle. Now the area of the triangle is a half AB sine C. Now you think to yourself, well, to get the biggest triangle I need the longest length. So here, if I look at the limits, it's going to be 7.15 to 7.25, and this is going to be 13.55 to 13.65. Now in terms of sine, the angle, well, that's going to be 109.5 to 110.5. Now what you want to do is see which angle it is we're going to use, because when we're multiplying, what the biggest numbers, but it's worth just double checking to see what sine 109.5 actually is, because we want the biggest number. So this is 0.9426, and then if I then do sine 110.5, so sine 110.5, it comes out smaller, so 9366. So in terms of the lengths, I want 7.25, 13.65, and an angle of 109.5. So the upper bound is going to be a half times 7.25 times 13.65 times sine of 109.5. And if I type that all into my calculator, I get an answer of 46.64, and that's in centimetre squared. Then moving on to the last question, it says here is a sketch of the graph y equals 5 to the power of x. In parts A and B, the sketch of y equals 5x is shown by the dashed line. So on the first one, we want to sketch the graph of y equals minus 5x. So for this, what you want to do is you want to reflect on the x-axis. So it's going to look something like that. Hopefully your curve is going to be a little bit smoother. And then on the very last question, is on the axis below, sketch the graph of 5x minus 1. So what we want to do is we want to shift the graph down by 1. So this point here is at 1. So if we shift that down by 1, it's going to be 0. So what you're wanting is a curve that's relatively parallel, but I would say would look something like this, but definitely goes through the origin, and try and keep the space between those lines relatively the same. And that's it.